See this problem. This is very simple. This is nothing but a triangle law. Okay, you are given the vectors. Express AC vector. That is the AC vector in terms of AB vector and CB vector. In the figure they given the direction also. So in a triangle law, what it says, all the vector in the same sense, right? This is going and this is also going, but this is coming opposite, right? So this sum should be equal to this, right? That's what resultant vector. In our case, what happened? AC plus CB should give you the AB vector. So what we are having? AB vector should be equal to AC vector plus CB, not BC. CB is moving from C to B. CB vector. Okay. Yeah, this is important. Don't put BC. That means you mean vector is opposite. Okay, we are giving C to B. So now what they want? Express AC. So what is, tell me what is AC vector? AC vector equal to AB vector minus CB vector, and that's what their answer is. Okay, simple. This is. Wait. Determine the resultant of 4 forces A1, A2, A3 and A4. It was given in the figure. So A1 is in this direction. A2, these all are represented by your direction and the magnitude. Okay. A1, A2, which is again this direction, A3, which is again this direction, and A4, which is again this direction. So obviously your resultant vector has to be A5. Okay, so how are we going to do? We have to use the triangle law. Okay, one by one we will use a triangle law. First we will take the combination of A1 and A2. So what will we do? We will join. Triangle law says the resultant due to this A1 and A2 will be a triangle joining this one. Okay, and we call it as OB vector, correct? So that will be what? Using triangle law, OB vector will be equal to A1 when vector plus A2 vector. What will be the direction of OB? This will be O to B. Yeah, that's what. Because this is this direction, that's opposite sense. Always when this is going, this it goes opposite sense. Okay, and then we will find out what will be the resultant vector of what's that? B? Why do you want to go for BD? Go one by one. Yeah, we can go that way also. Okay, fine. Let us do that. BD. Yeah, this is also going like this. This is there, right? So this one has to be. Okay, if you want to go by that way, so let us do that. BD vector. So what will be the direction of BD vector?
B to D.
This one, B to D. Correct? So, therefore, tell me, what will be BD vector? BD vector will be equal to A3 vector plus A4 vector. Okay. So, remember, so these are the resultant of all the 4 vectors we got. A1 plus A2 we got, this is A1 vector plus A2 vector, and this will be A3 vector plus A4 vector. Now we want to find out the resultant of these 2 vectors. That's your A5 vector. Correct? So what we will write? The resultant vector is OD vector, because see this angle, this direction, the same sense, so OD has to be opposite sense, correct? So will be is OD vector, which is given as A5 vector. Okay, actually in fact they wouldn't give this A5 and this direction. Okay, so in fact they won't give you this line also. This is a vector, you have to find out resultant vector. Okay, this line we have to draw. Got it? Because these 2 is there, so then we have to draw it. Let me, the line which you have to draw, I'll draw it the red color. Okay, and this direction has to be opposite sense. Correct? And let us call it as A5. A5 vector will be what? Tell me.
A1 vector plus A2 vector. The sum of all the vectors.
Yes, correct. That's it. So it will be equal to what? a1 vector plus a2 vector plus a3 vector plus a4 vector. So that's what your resultant of the all four vectors. Okay, this is an interesting question. All questions are interesting in physics. Okay, a stream flowing with a velocity 5 km per hour. Okay, there is a stream which is flowing at 5 km per hour in the east direction. So we have the north, south, east, west. You know what is north, south, east, west? This will be, if you write, this is what? North, south, what? East? Sure? And west. Okay. So a stream is flowing with a velocity 5 km per hour in the east direction. And the speed of a boat in a still water is 20 km per hour. So in a still water it goes 20 km per hour. And now the boat enters the stream heading in north. That means it's going to enter from here. So what should be the... So of course the stream is going to pull the boat along this eastward direction, but the boat is going to move along the northward direction. So there can be a resultant. There are two vectors already attained. Correct? What should be the velocity of the vector? When you say velocity of the vector, you have to find out the magnitude. What's the magnitude? As well as the direction also. When is a vector, I said, whenever you have a vector, vector has both the magnitude as well as directions. When they ask what velocity the boat actually travel, velocity is a vector. So you should find out the magnitude as well as the direction. Correct? So how we will do it? So let us do it. Let us draw the vector diagram. 5 km per hour in east direction. So how the way you have to draw? We typically take a line of 5 centimeters. Okay, so this is the velocity of the stream, which is 5 km per hour. With the magnitude, we got 5 centimeter line. Okay, there I am just drawing it. When you are drawing in the notebook, you have to draw it in a 5 centimeter line. Okay, and the speed of a boat in still water is 20 km per hour and is, oops, I made it wrong. It's entering from here, na? So let me put it, draw. I don't have a space otherwise. So this is what? 5 km per hour. This is the 5 centimeter. You can take whatever the units, 5 centimeter, whatever you can. You have to scale it properly. And the speed of the boat is 20 km per hour. Now it's entered the stream heading the north. That means the boat is entering over here. Okay, so if there is no this stream flow, okay, if there is no flow, this is the direction the boat will move. Am I right? If there is no flow in the water, it's still water, it's moving in northward side. So this is the one. So what will be the length of this one? Tell me. 20 So 20 km per hour. When you draw, I have drawn it small. This should be typically 4 times of that. So, okay. So this will be what? 20 km per hour. So what will be the resultant? What will be the resultant velocity? Triangle law. I have to connect like this. Is it right? Can we connect like this? Are they both in the same sense? Correct? So which law you have to use? The vectors. Yeah, because what happened? Your vectors, the tail of the vectors are joined. I told you, na? So when they are connected, then you can do that. Okay, so if otherwise what happened? You have to draw an equal vector. If you want to use a triangle law, then you have to draw equal vector of this here. You have to draw an equal vector here, and then these are same sense. Okay, and then you can connect it. You got it? And that will be anyway same. Because your parallelogram law is also basically same. You draw a parallelogram and then you connect your, this is a parallelogram. Here parallelogram is, since these are perpendicular, it's become a rectangle. And then you connect your diagonals, right? So, and this is your resultant velocity V of the boat. Okay. Tell me, so what will be the magnitude? We have resolved into, so the resultant vector. So what happens? So this vector is like this and this is like this. Let me call this as A vector and this as B vector. Okay. So what happened? A vector equal to 5 and 5 UA, let me call. That's the direction. Sorry. 5 UA cap. And the B vector will be equal to 20 UA. UB. Okay. So therefore, so we have the resultant vector. This is what I am going to call V. So V vector, magnitude of V vector will be equal to, what is the formula we had? If you remember what we had? V square A square plus B square plus 2AB cos theta. Yeah, correct. Cos theta is 0 because the angle between these two vectors is 90 degree. So this is the angle 90 degree. So this is 0. So what is going to become? So V square will be A square plus B square. Okay. So tell me.
V equal to root of 400 plus 25.
25 plus 400. So what this will be? Root of 425. Tell me what it is. I think whether the units are same. Yeah, correct. Okay, so you can do, you know how to do the square root. You can do it and it's directly writing the answer. So this will be 20.61 kilometer per hour. So this is the magnitude of your what do you call, of the velocity. Okay, but that is not sufficient. We need to give a direction also. So this gave you the magnitude. So the boat is going to move even though in the still water, the boat travels in 20 km per hour. Now since it is moving in a stream, so it's going to slightly increase the magnitude, 20.61, because a component of river also has come in. River speed also has come into it. Okay, but now of course the direction is not going to be same. To find the direction, you need to get some alpha. Right? What is that alpha? If you give me this alpha, that gives the direction at an angle this much from the stream, from the eastward direction. Okay, it moves with velocity this magnitude and an angle theta, this alpha from the eastward direction. That direction also I gave. All you have to find out is angle. Tell me what's the formula for alpha, tan alpha.
Tan alpha equal to A cos.
You remember that what we did?
A cos theta.
Tan alpha will be equal to A sin theta, correct. A sin theta divided by B plus A cos theta. Okay. Anyway, cos theta is 0 because 90 degree and theta is angle between the two vectors. Sin theta equal to 1. So this will be A by B. A by B. So A is equal to what? I think 5 by 20, correct? So that is 1 by 4. But we have, let me write it down. A equal to how much? This is the magnitude of A. This is a unit vector. So this is a magnitude. 5 by 20 equal to 1 by 4. That's the alpha. Okay. So if you want to find alpha, what happens? So alpha will be equal to tan inverse of 1 by 4. You don't have to find the answer for it. Just leave it here. Okay. So this gives you the, so this two. So this velocity magnitude as well as this gives you the complete vector of the, what is the final velocity of the boat. Okay. And if you actually do, this comes out to be 14 degree and 4 minutes. Okay, so it moves in the, so it moves along at a 14 degree and 4 minutes angle. Okay, so that's what the answer is. So see this problem. Find a unit vector in the direction of a vector 3 I cap and 4 j cap. It's So it's in a two dimension. I is along the x-axis and j is along the y-axis. So can you tell me what will be this vector? So this is x, okay, and this is y. Can you tell me where will be the point? Okay, or let me draw the vector. That will make it easier. So I am drawing the vector. Let this be the vector here. Tell me what will be this point P. This is O. Seeing from here.
I is of x, right?
Yeah.
So 3, 4.
Correct, exactly. 3, 4. Okay, because that's a magnitude, na? Because, so what it says, this is, magnitude is 3 and the direction is I cap. And here, the magnitude is 4. Okay, and the direction is j cap. So this is what a vector is. So you wanted to find out, so this is a vector. So when they get 3 I cap plus 4 j cap, this should be 4 j cap. 4 j cap, so that will be a vector. So now what they're saying, so this is the vector they are given. Find a unit vector in the direction. Along this direction, you have to give the unit vector. So let me call this vector as, give me a name. What is the name we will give? A vector. Okay. So you know the unit vector UA cap will be A vector divided by the magnitude of A vector. Do you remember that? So now we have to first find out the magnitude of A vector. So A vector is given. What is A vector? A vector is given already. Right? That's what this vector is. 3 I cap plus 4 j cap. Magnitude. What will be the magnitude? Tell me.
It's the OP, distance of O to P.
That will be 5. Why?
Because this will be root of 3 square.
Correct. You should do. Okay. Tell that. Okay. So magnitude of A, if you remember, we saw that parallelogram. Use the parallelogram property, na? So the magnitude of this vector will be this square plus this square. What happened? So your magnitude A square will be equal to 3 square. 3 square plus 4 square plus 2 into 3 into 4, 2ab into cos, here it is 90 degree. So that becomes 0. So this goes off. So what you are going to have 3 square plus 4 square. So that will be how much? 25. Therefore, A equal to 5. Root 5. Root of 25, so A equal to 5. Not plus minus. Okay, because the magnitude. So this will be equal to, so we are having, so therefore, A, that's what magnitude of A equal to 5. Therefore, your UA cap will be, let us substitute A vector. What is that? 3 I cap plus 4 j cap divided by 5. That will be equal to 3 by 5 I cap plus 4 by 5 j cap. That's what your formula answer is. Okay? That's what. So this is your unit vector in the direction of the vector, given vector. Okay? This is a simple problem. Given a vector I plus 2j, I cap plus 2j cap, b vector 2i cap plus j cap. So these all are vectors, correct? Which are resolved into along the x and y axis. And what are the magnitude of these two vectors you have to find out, and you want to find out are these vectors equal. By looking itself you can say the vectors are not equal. Why? Because when you resolve the x components and the y magnitude of x components should be equal, which is not. Okay. So first let us see. Find out the magnitude. Magnitude of A is what? So the A vector, magnitude of A vector will be equal to square root of, what is the magnitude of this I component? 1 square plus 2 square, that will be equal to what? Root of 5. So what is the magnitude of B vector? Sorry. Tell me. 2 square, x magnitude is 2 square plus 1 square, that will be equal to root of 5. So of course the magnitudes are same. Okay, the magnitudes are equal. Therefore, the magnitudes are equal. But the direction won't be equal because the individual component is okay. But the direction is not equal. Okay, the reason is why? Because the I component, the I component is where it is 1, here it is 2, 2 component is equal to 1. Okay, therefore these vectors are not equal. Okay, so you have tried it as write in the proper language. Okay, so the magnitude of ith component and the magnitude of jth component are not equal. Therefore, these two vectors are not equal.